Having learned the laws of indices, the basic laws of indices, we are right here to study exponential equations or initial equations. So a basic knowledge of the laws of indices is required to move on in this class. So let's move together. The first question on the board is, we are asked to solve 2 to the power of x is equal to 16. Now, what we are going to do now is to express 16 in index form. I know that 2 raised to the power 4 is equal to 16. Good. At the left hand side, I have 2 raised to the power x. So, when you see a question like this, the left hand side, maybe it has a base and an index. What do? Make the right hand side to also look like the left hand side. So right here, I can cancel 2 because they have the same base. So in indices, when you are solving any exponential equation, when the bases are the same, equate the powers. And in the same vein, when the powers are the same, equate the bases. Right here, the bases are the same, so I will equate the powers. X is equal to 4 is the answer to this equation, to this question. Now the next question. I'm asked to solve 3 to the power of x plus 2 is equal to 1 over 27. So what I'm going to do here first of all is to clear this fraction. And by the law of indices, 3 to the power of x plus 2 is equal to 27 to the power of minus 1. So based on the law of indices I taught you guys, 27 can be expressed as 1 over 27 is equal to 27 to the power of minus 1. So right here, I have a term at the left hand side, and it is to the base of 3 to the power of x plus 2. So right here, I have 27 to the power of minus 1. So I will possibly look for a way if I can write 27 as 3 raised to the power anything. Yes, I can actually write 27 as 3 raised to the power 3. Good, 3 raised to the power 3. Remember, they are all raised to the power minus 1. And right here, I have 3 raised to the power x plus what? 2. So, based on the law of indices also, I have 3 to the power of x plus 2 is equal to 3 times minus 1. That's 3 raised to the power minus 3. 3 times minus 1 is minus 3. And based on what I told you just now, that if the bases are the same, equate the powers. So right here, the bases are the same, I'll cancel them out, so that x plus 2 is equal to minus 3. So we'll solve the resulting equation and we'll get the answer for x. So x is now equal to minus 3. Collecting like 10, this plus 2 crosses and turns to minus 2. And the answer is equal to minus 5. So x here is equal to minus 5. This is the solution to the second question. 3. We have 1 over 2 to the power of x plus 1 is equal to what? 8. Right now, I want to do something very easy and simple. What I'll do now is to first of all eliminate this fraction that I have here. And it becomes 2 to the power of minus 1. Based on what I told you here, if you have a fraction, take the reciprocal of the fraction and the index turns to negative. So 2 to the power of minus 1 or raised to the power of x plus 1 is equal to what? 8. And let me let you know that I can actually write 8, express 8 as what? 2 to the power of what? 3. 2 times 2 times 2 will give me 8. So I will work with this 2. That is 2. This negative 1 will affect this x plus 1. So negative 1 times x is negative x. Negative 1 times 1 is what? Negative 1 is equal to 2 to the power of 3. Good. So, because the bases are the same, what will happen? They will cancel out. Minus x minus 1 is equal to 3. Equate the powers. So I have minus x minus 1 is equal to what? 3. So minus x minus 1 minus x is now equal to, collecting like terms, 3. By the time this minus 1 crosses down to plus 1. So minus x is now equal to what? 3 plus 1 is what? 4. So dividing both sides by minus 1, x is now equal to minus 4. So minus 4, x equal to minus 4 is the solution to these exponential equations. So we are moving to a more difficult part of this exponential equation in the next video. I'll see you there. Don't forget to subscribe, don't forget to like, and don't forget to share.